I welcome you all for this lecture of computer-aided process planning. Right? In this image, which we have shown in the screen itself, you can visualize this. What is the role of the computer has made in the day-to-day scenario when you are comparing the ancient times. Right? This image shows that a piston which has been clear-headedly designed with the use of a computer with a very good accuracy and the preciseness. The main purpose of using the computer-aided process planning and industrial scenarios is it improvises the nature and quality of the product in order to uh, attract the customers. That is the main reason behind we are going for the computer-aided process planning technique. Because when you are comparing the earlier period, the techniques which has been implemented are not been up to the mark, right? Because due to the manual errors. So the manual error has been equipped and they are being tremendously improved into a computer based planning in order for their accurateness, right? So what are the approaches in process planning? There will be a plenty of approaches, but the main focus has been given on both approach called first one manual experience based process planning, computer aided process planning method. So these are the two well-fledged process planning methods available in day-to-day scenario, right? First one, manual experience based process planning. What is meant by manual based? Suppose, for example, we can say that an employer who is not even educated can make a well executed manual experience based process planning. How? Because an employer who is not been basically educated, suppose imagine that he is working in a concern for 10 number of years and performing repeatedly the operation for several times. Now he can identify that through his experience, whatever he has experienced for the 10 years, he can easily identify what are the errors will come and what are the approaches we need to rectify that error or stop that error with his manual experience, right? These type of approaches are not being more efficient due to the skill set of the labor. You can't expect every employer to have a same skill set as he needs to experience for the manual experience based process planning method, because it is completely or purely depending upon the skill set of the employer. But what about the second layer, computer aided process planning? The initial layout of the process planning has been made and it has been tremendously increasing the accuracy due to this non-dependability or independency over the external factors. So how you could how you could implement this? These are the essential steps. First one, the first step of implementing the CAPP is design input. For any form of methods or product you are going to create, the design input plays the vital role. The design, whatever the design has been provided by the customer, needs to be looked over from top to bottom. The entire sheet of the drawing needs to be completely analyzed, and based upon the design we need to go for the material selection. My design should have what type of material should be decided properly, right? For example, we can take a chassis. We can take a chassis of an automobile. The automobile chassis, comparing to the earlier stages, now the material weight has been completely reduced. Why? Because in terms it has been reduced in order to improve the efficiency. In order to improve the efficiency. So at that place, the material selection plays a vital role. The next factor, process selection and process sequencing. So design input we have got. So depending upon the design input, we have selected some material. So depending upon the material selection, we are going for the what type of process is suitable in order to equip this material into the finished goods. So after selecting the proper process selection, we need to go go for the process sequencing. As we have already illustrated that process sequencing plays a vital role because the finishing type of operations cannot be executed at the initial stages of the machining. So the next one, machine and tool selection. So once design freezed, then material has been properly selected, then followed by the process selection, then the sequencing of process has been arranged properly. Finally, they will go for the machine and tool selection. So what is the type of machine I am going to use and what is the type of tool which I am going to implement on this machine. Finally, intermediate and surface determination. So after deciding that this is a machine I am going to implement and this is a tool I am going to use, I am going to be deciding of the fact of what is the surface contact I am going to implement on this particular type of process. So the last areas are fixer selection. So I have decided the machine and other thing, what are the type of contact. Now how I need to going to lock the degrees of freedom. So either I need to lock completely or I need to lock certain degrees of freedom alone. Depending upon that, the fixture has been designed. Suppose for example, we can say that the fixture can be optimized with some principles in order to increase the efficiency. These also could be possible as CAPP. So after the fixture design, suppose for an example, we can say that we need 12 degrees of freedom to be locked. 12 degrees of freedom to be locked on a fixture. There it could be optimized with a CAPP model where the principle 3-to-1 principle, due to the usage of 3-to-1 principle, instead of locking 12 degrees of freedom, you can lock only 6 parameters. This could be also possible in your computer-aided process planning technique. So finally, machining parameter selection. Then as of a layer of that, the economics has been placed. Finally, the cost and time estimation. Then final plan preparation. So these are the steps involved in cultivating the CAPP. So the computer-aided process planning, this is the overall layout of the chart where you are going to start up with the part family matrix file. So the initial layer of the design has been started with the part family matrix file. So that part family file has been formed as a header data. They are grouped into a header data, right? So these parts are going to be completely compiled into this type of header. For example, you can say that the engine piston and the piston assembly can be enclosed within the cylinder head. Then they are framing some form of standards. Then after framing or completing the standards, they are going for the retrieval operation. Either we have made some type of product or some layer of product in a earlier with respect to this type of design. Finally, work element processing. If all these types have been completed, then finally a process plan has been formulated. So this is the basics of CAPP which we have witnessed in this video. Next video we will witness of the types of CAPP. Thanks for listening this lecture.